let's go with some more integrating. So remember with taking the derivative of the natural log of the absolute value of x, remember natural log of u was u prime over u, so the derivative of, that your u is x, the derivative of that of course is 1, and so you got 1 over x, which means 1 over x is the derivative of ln of absolute value of x. So if I say integrate 1 over x, then who has a derivative of 1 over x? That would be natural log, and notice that the absolute value shows up here. So you have to put the absolute value marks there. They don't show up in the question, they show up in the answer. And this should make sense because, again, when you have a quotient, look for u prime over u, and I want to be very clear that I can say u prime over u. This u prime is like du, okay? So if I say du over u or 1 over u du, all of that's the same thing. So as we talked about, you go, well, how do I know to make it be the denominator? Here's the deal. In reality, what you're doing, if I said write this as a power, would you agree that that would be x to the negative 1? So when you get that power, think about integrating x to the negative 1. You're like, oh, it's a power, so let's use the power rule. Increase the power by 1 would be x to the 0 over 0. Well, that doesn't make sense. Friends, if you write a power of negative 1, it's going to be most likely an ln problem. So you're going to think, oh, I'm not going to do this by power rule. I'm going to think of the natural log. So one good choice of u is the denominator. And honestly, I kind of look for this one as we're mixed in an AP, and when you get to the test, this is kind of the first one I look at and figure out. So let's look at this integral. The first thing, it's very easy to see if it's going to be a straight natural log problem, because if I let u be the entire denominator, notice that's the whole thing, well then du is going to be 5 dx. And remember how it's written this way, this dx, that's like multiplying by dx. So in reality, if I wanted to, I could write the problem like this. That's having dx on top. So don't get confused on how they type it, because it could be typed more than one way. So what do you really have? You have, well, 5x plus 2 is u. 5 dx is du. So again, that's the same thing as how I just wrote it in a different way there. 1 over u du, or du over u. How does that integrate? ln absolute value of u plus c, and then I substitute back in. So my answer is this right here, plus c, and I'm done. So if I let u be the entire denominator, it becomes a very simple problem. Now let's look in example 2. Once again, let me start out by thinking, is it going to be a straight natural log? Here's how you decide. When you do du and I get 8x dx, friends, this variable has to be in the numerator. If I had an x squared on top, or that x wasn't there, then it's not going to be a straight ln problem. But since I have that, I'm like, yep, this is going to be an ln. So let's watch. And I'm going to write this one a little different way, and you can pick the way that makes sense to you. Again, this whole thing is like in the numerator. So x dx, just like I solved for x dx before, do you see that that's du over 8? So I'm going to put the du here, but I'm going to put the 1/8 on the outside. And then what do I have? I have 1 over, well, 4x squared minus 7 is u. So I have 1 over u du. That integrates to 1/8 ln absolute value of u plus c. Now let's pop that u back in there. Plus c, and you are done. There you go. Now, what do you think you should do on example 3? I want you to try both examples 3 and 4, and hopefully you kind of see it. Well, I'm hoping on example 3 you go, Ms. Pruitt, that's not even a u substitution problem, because I know when this is just a monomial, I want to just divide. So that problem, just like, not that you have to show all these steps, you're like, well, I could write that like this. I could undo the common denominator, if you will. I mean, isn't that true? So that's really just the integral of x plus 9 over x dx. Now, I do want to write this separately because, believe it or not, this is one of the most missed things. As you go down the plus, you're actually integrating each individual thing. So you're integrating like this. And I'll tell you why I wrote that this first time, is because, again, this integration is not hard, 1/2 x squared. Now, how do you integrate 9 over x? Well, that 9 is already in there. So I can just move him to, get him out of the way. I can just move him to the outside, and I would get an answer of 1/2 x squared plus 9 ln of absolute value of x plus c. The reason why I split them up is because here's what a lot of people do. They go from this step and they go, oh, 1/2 x squared, I'm going to bring that 9 in front, so they make this a 9, and they put 9 ln of absolute value of x plus c. They put a 9 on that front one as well. And you don't do that. Remember, as you're doing the pluses, you're doing individual integrals. So when you pull that 9 outside the integral, it is only in front of this guy, not that one as well. So again, not that you have to write each of those steps, I just wanted you to be aware of that and not make that mistake. So let's try example 4. Well, you've said let your u be x squared plus, let it be the entire denominator. So du is 2x plus 2 dx. And you said, well, Ms. Pruitt said that I'd have to look in the numerator, and what's in the numerator has to resemble this variable-wise. There could be a constant difference, and hopefully you see it. You're like, oh, they can't trick me, because I could write du as 2x plus 1 dx. Well, piece o' cake, because I can solve for x plus 1 dx. Once again, that's what I have right here. That would be du over 2. So I just have the 1/2. And then I'd have 1 over u. And so I'd have 1/2 ln of absolute value of u plus c. So my answer is 1/2 ln absolute value x squared plus 2x plus c, and there you have it. All right, so hopefully you're kind of getting the hang of it. So let's try some more advanced ones. Let's look at this one. See what you think you should do. Is this going to be an ln problem? Well, remember, think about writing that. That's really like this. Plus 1 to the -3rd x dx. Remember, ln is when you have something to the first power, because really on these problems before, like example 2, I could write that as 4x squared minus 7 to the -1 x dx. The reason it was an ln is because the power is to the -1. But on example 5, this is not going to be an ln problem because in reality, the whole derivative of that thing and the entire denominator would have to be on top, and that's way more complicated. So this is a problem that you could have had the other day, but I like throwing those in your homeworks like that because you've got to get in the habit of looking for it and making sure that you can distinguish when to do what. So du would be 2x dx. So I would have u to the negative third. X dx is du over 2. So you have u to the negative 2 times the negative 1/2 times 1/2 plus c. So my final answer would be negative 1/4. My u is x squared plus 1. I'll just put it in the denominator plus c. And there you go. All right, let's look at example 6. It's a tricky one. Again, start fumbling around. Think, okay, well, you said to put the entire denominator as your u, but good gosh, if I start doing du, I'd have to do the product rule first times the derivative of the second plus the second. I'm going to have an ln of x. That doesn't seem right. So nope, not that. Let's try something else. Let me give you a hint. Maybe look at this problem like this. Think about writing it in different ways. Maybe like that. Maybe that might help you if I wrote it like that. Isn't that the same thing? I just algebraically wrote it. And maybe you see it. Your u is actually ln of x. Du is 1 over x dx. So what is this saying? It's 1 over u. All of this is du. So I'd have ln, absolute value of u plus c. And what is u? Well, u is ln of x. So my answer is this weird looking thing, like that. All right, last one. So again, we have a u sub where I'm actually finding a definite integration. So just like we said yesterday, you could leave it in terms of u. You can change the bounds and leave it in terms of u, or you don't have to change the bounds and take it back to x. So whichever way you prefer there. My u is going to be x cubed plus 1. Du is 3x squared dx. So when I integrate, here is u. For x squared dx, that would be du over 3. And like I said, I am a person, I do like to change the bounds. So that's my thing. I like that. So x and u. So if x is 2, then u is going to be 9, because 2 cubed is 8 plus 1. If I plug in 0, that would be 1. So I like changing my bounds. It just makes it simpler for me. So I have 1/3 ln absolute value of u, and I need to evaluate that from 1 to 9. So I have 1/3 ln of 9 minus ln of 1. Now I could do two things here. One is I would realize that natural log of 1 was 0, so that would go away. I could also use this log properties, knowing that if I have natural log of a minus natural log of b, I could divide. So either way, I get 1/3 natural log of 9. But remember, the reason I put the log properties is because you might have to, what if that's not on multiple choice? Look at this log property. I could also take that as an exponent, so another correct answer would be this. So you have to remember those log properties because you never know how it's going to be written on multiple choice. Last thing I want to mention, I'm just going to do this problem very quickly. If I let u be x squared plus 1 and du be 2x dx, Notice I really have just du over u. So that's natural log of u plus c. Notice here when I write this final answer, why is it okay and acceptable for me to write it with parentheses? Now, if, on free response, if you wrote it with absolute values, would I give you credit? Yes, but I just wanted to point out, so you're like, wait, Ms. Pruitt said that every time that you integrate and get natural log, you're going to have absolute values. Well, if this argument is guaranteed to be positive most of the time, then the absolute values aren't necessary. So they write the answer with parentheses rather than absolute value. It's not wrong if it's absolute value. It's just I wanted you to see one where I didn't want you to think on my answer key, if I wrote it with parentheses, you think, oh, she forgot the absolute value. If the argument is always positive, then it's going to just be, you can write it with parentheses. Okay, so remember what things are already always positive. X squared plus e to the x, like exponentials, or 3 to the x plus 1, those are always positive. All right, good luck and peace out.